Following on from the previous video, we said that there exists a value of c somewhere in between a and b, where the gradient of the actual function is the same as the average gradient. And remember, the condition we placed upon this function here is that the function must be continuous and differentiable, okay, at all points between a and b. So now in this video we're going to try and disprove this theorem here. Try it for yourself. Try to break this thing down. So it's like me asking you to try and draw a function in such a way that this does not hold. Okay, so try it for yourself. To try to draw a function. I don't know, something like this, where you see, no matter what function you draw, there must be somewhere in between. Hang on, let me just take this down. No matter what function you draw, and then slowly move it up. No matter what function you draw, there must exist a point C somewhere where the gradient, you see, right at this point here. Right at this point here. Hang on, bear with me. Right at this point here. Right at this point here, the gradient of the actual function, the gradient of the actual function is the same as the average gradient here. It's the same. See, these two lines are or parallel. So try to break this down for yourself. Try to break it down. Try and come up with a hang on, bear with me. Hang on, bear with me. Try to come up with a function where this thing here does not hold. So no matter what function you draw, there must be a c somewhere in between. That will be the same as the average. So hang on, let me so no matter what function you draw, so let me just move it all the way to the top and then move it down here. You see, right at this point here, right at this point, well, there exists at least one. There must exist at least one where the gradient of the the actual function will be the same as the average gradient. You see these two lines here. This line here is parallel to this line here. There happen to be another one here, but the point is that there exists at least one C somewhere in between. Okay, you may try something like this. You may try something like this, and then all the way across here. But then this here is not. It's not really a function here, because remember, a function is when you put one value in and then you only get one. It only spits out one value. Here you put in a and then it's spitting out. I don't know, e here. So it's spitting out e here, and then it's also spitting out f here. So this here is not a function. It's not a function. So you cannot use this. You could try something like, okay, so hang on. You could try something like this. Bear with me. You could try. So this here is the average gradient. This here is the average gradient. This here is this bit here. Okay. You could try something like this. You could try and break this down by doing this. Okay. I'm gonna I'm gonna create a function where it will join a and b together, but I'm going to keep my gradient just below the average gradient. You see, at the moment, this gradient here is always lower than the average gradient. You see, it's always average. But in order for me to join up b, my gradient has no choice but to get steeper and steeper. So here, somewhere in between, well, I was doing well up to this point here. You see, the gradient here is below the average gradient. But in order to join up with b, then I have to get steeper. Therefore, there must exist a c somewhere in between. Well, up to here. Hang on. You see, my gradient here is always below the average gradient. But here, somewhere there, my gradient is steeper than the average gradient. You could do something like this. Look, from here to here, it's quite, the gradient here, from here to here, the gradient is quite shallow. It's actually below the average gradient. But then somewhere in between here, I have to, somewhere in between here, the gradient is steeper than the average gradient. So no matter what you do, you're going to obey this theorem here. You try and break it down. It's draw a function in such a way that Yeah, draw a function where it crosses f of a and f of b. You must somewhere in between there must exist a c where the gradient of the actual function will be the same as the average gradient. Try to break it down for yourself. I don't think you can do it, but try. Okay.